Hello everyone, my name is Surush and I'm a PhD student at the University of Windsor. In this video, I want to talk about the SEERa, our Python-based and open source framework for future community prediction using the information from social networks. In previous video, I mainly talked about the workflow and the layers of SEERa, but in this video, I want to mainly talk about the installation and code structure of SEERa, and at the end of this video, we will have a quick run on a toy example. I'm using Google Colab for this video. So as you can see in the left panel, we have a folder for SEERa and we have a source folder in here, contains all of our code lines, and the main code base is in this part. So we have a couple of subfolders, and each one is for each layer of SEERa. For example, the TML is for the topic modeling layer, or the DAL is for the data access layer. But the main entry point of the whole pipeline is this file in here named main.py. And every other functions and layers are called from this file. And also, we have another file in here which contains all of the parameters of our framework, as you can see in the right panel. The params.py includes a dictionary, and the keys of this dictionary also is for every different layers. For example, this one in here, DAL, contains the parameters for the data access layer, which is the user modeling and time modeling flags, and the start and the end date, the time interval, which is set to 1, which means we want to aggregate the tweets of each user's daily. For example, if it is set to 3, we aggregate the tweets from the users for every 3 consecutive days. And for example, for TML, we have number of topics in here, or library, which equals to gensim for this sample run. It can be also set as mallet, another library that we used for extracting the topics using the LDA. And also, for example, for GEL, the graph embedding layer, we have embedding dimension in here, which is set to 30, and the method, which is dynaerrn in here. We have multiple other methods for different layers of SEERa. For example, for the GEL, we have implemented the node2vec, or also we used multiple neural network based models like dynaerrn or dynae, or maybe some other libraries that you can see in this part on our GitHub page. For example, for graph embedding, we have the node2vec, AE, autoencoder, dynamic autoencoders, dynamic recurrent neural networks, and so on. So after setting these parameters, we can run the whole pipeline. But first, we have to clone and download our framework. To do so, we have a command in here, git clone recurse submodule J8, because we are using some external libraries in our framework. Using this command, you can download the whole package together. After that, we will change the directory to SEERa, and using this command, pip install-r requirements.txt, we can install all of the requirements for SEERa. After downloading and installing the requirements, we will be here in SEERa folder, so we change the directory to source folder to access the main.py file. Then using this command, python main.py, we can run the whole pipeline by just entering one command. This block in here represents the output and likes of the SEERa for our sample run. As you can see, we have more than 62,000 tweets from more than 7,000 users from the November 1st to November 19th. And we set the time interval to 1, which means that we aggregate the tweets daily. And if you set the time interval to 2, for each 2 consecutive days, we aggregate the tweets from the users. Then topic modeling layer applies an LDA model on this corpus and tries to find the most 75 major topics from the whole corpus. And using this information, the user modeling layer tries to find a user topical preferences for each day. So we have 19 matrices in here. Each of them has 7,000 rows, and each rows represent the topical preferences of the users, and the topical preferences are shown with a vector of length 75, which is the number of topics. So at the last of this layer, we have 19 graphs. So we decided to use a temporal graph embedding here to aggregate the temporal information from the first day or first graph until the last day just into one matrix. So the last embedded matrix contains the temporal information of the whole data set from the first until the last day. So using the dynamic autoencoder recurrent neural network method, we have also other methods like node-to-bake autoencoder and so on. But we decided to use the dyne-AERNN for this sample run. Using this method, we can achieve a matrix with dimensions of 7,000 to 30, which is the location of the users in the latent space for the future time interval. Suppose that we had a data set from November 1st to November 19th, and we set the time interval to 1. So this matrix represents the user's location for the next day, which is November 20. Then we apply some clustering methods on our predicted matrix. We use the Louvain graph clustering in here. We can use any graph clustering methods, or we can use any other ordinary clustering methods directly on this matrix. And using a clustering method on the predicted matrix, we can predict our communities in the future or in the next time interval. For this sample, we could extract 2,000 communities for the next day, but most of them are singleton, which means they have just one user. But by the definition, we decided to use the communities, or we decided to consider the clusters as communities if they have more than 2 users. So we can predict 14 communities for the next day. And for example, this one, the first cluster, may have more than 600 users, and their favorite topic is probably the topic number 26 with this probability. And the topic number 26 is about Harry Potter. So if we want to recommend the users in this community something like an item or news article, we can expect that if that item or news article has the same topic as topic number 26, or if it's about the Harry Potter, we expect that more than 40% of the users will be interested in that item or news article. And so on. You can see that we have 14 communities in here, ordered by the number of the users. Overall, put more focus about knowing the communities in future is very important, because it can help us to improve other applications in social IR, like query refinement using the social information, or like the item recommendation or news article recommendation. Thank you very much. This was our second video on SEERa. If you have any questions about the code lines and dataset, you can contact us. Thank you very much for your attention. Have a great day and night. Goodbye.